LEDs to optical fibers for high-speed data communication links. Miniature. These are mostly single-die LEDs used as indicators, and they come in various sizes from 2 mm to 8 mm, through hole and surface mount packages. 129. Typical current ratings range from around 1 mA to above 20 mA. Multiple LED dies attached to a flexible backing tape form an LED strip light. Common package shapes include round, with a domed or flat top, rectangular with a flat top, as used in bar graph displays, and triangular or square with a flat top. The encapsulation may also be clear or tinted to improve contrast and viewing angle. Infrared devices may have a black tint to block visible light while passing infrared radiation. Ultra-high output LEDs are designed for viewing in direct sunlight. Image of miniature surface mount lids in most common sizes. They can be much smaller than a traditional 5 mm lamp type LED shown on the upper left corner. Very small, 1.6, 1.60, 35 mm, red, green, and blue surface mount miniature LED package with gold wire bonding details. 5V and 12V LEDs are ordinary miniature LEDs that have a series resistor for direct connection to a 5V or 12V supply. High power. High-power light-emitting diodes attached to an LED star base, Light-Emitting LEDs, high-power LEDs, HP LEDs, or high-output LEDs, HO LEDs, can be driven at currents from hundreds of mA to more than an ampere, compared with the tens of mA for other LEDs. Some can emit over 1,000 lumens. 130, 131. LED power densities up to 300 W/cm2 have been achieved. Since overheating is destructive, the HP LEDs must be mounted on a heat sink to allow for heat dissipation. If the heat from an HP LED is not removed, the device fails in seconds. One HP LED can often replace an incandescent bulb in a flashlight, or be set in an array to form a powerful LED lamp. Some well-known HP LEDs in this category are the Nichia 19 series, LUMI-LEDs Rebel LED, Osram Opto Semiconductors Golden Dragon, and Cree-X lamp. As of September 2009, some HP LEDs manufactured by Cree now exceed 105 lm/W. 132. Examples for Haigh's law, which predicts an exponential rise in light output and efficacy of LEDs over time, are the Cree-X Peak Series LED, which achieved 105 lm/W in 2009. 132, and the Nichia 19 series with a typical efficacy of 140 lm/W, released in 2010. 133, AC-driven. LEDs developed by Seoul Semiconductor can operate on AC power without a DC converter. For each half cycle, part of the LED emits light and part is dark, and this is reversed during the next half cycle. The efficiency of this type of HP LED is typically 40 lm/W. 134. A large number of LED elements in series may be able to operate directly from line voltage. In 2009, Seoul Semiconductor released a high DC voltage LED, named Acrich MJT, capable of being driven from AC power with a simple controlling circuit. The low power dissipation of these LEDs affords them more flexibility than the original AC LED design. 135. Strip. A LED strip, tape, or ribbon light is a flexible circuit board populated by surface mount light-emitting diodes, SMD LEDs, and other components that usually comes with an adhesive backing. Traditionally, strip lights had been used solely in accent lighting, backlighting, task lighting, and decorative lighting applications, such as cove lighting. Increased luminous efficacy and higher power SMDs have allowed LED strip lights to be used in applications such as high brightness task lighting, fluorescent and halogen lighting fixture replacements. A LED strip on a reel indirect lighting applications, ultraviolet inspection during manufacturing processes, set and costume design, and growing plants application specific. RGB SMD LED composite image of an 1144 LED matrix lapel name tag display using 1608/0603 type SMD LEDs. Top, a little over half of the 2186 display. Center, close-up of LEDs in ambient light. Bottom, LEDs in their own red light. Flashing LEDs are used as attention-seeking indicators without requiring external electronics. Flashing LEDs resemble standard LEDs, but they contain an integrated voltage regulator and a multivibrator circuit that causes the LED to flash with a typical period of 1 second. In diffused lens LEDs, this circuit is visible as a small black dot. Most flashing LEDs emit light of one color, but more sophisticated devices can flash between multiple colors and even fade through a color sequence using RGB color mixing. Flashing SMD LEDs in the 0805 and other size formats have been available since early 2019. Bicolor B-color LEDs contain two different LED emitters in one case. There are two types of these. One type consists of two dies connected to the same two LEDs antiparallel to each other. Current flow in one direction emits one color, and current in the opposite direction emits the other color. The other type consists of two dies with separate leads for both dies and another lead for common anode or cathode so that they can be controlled independently. The most common bicolor combination is red/traditional green. Others include amber/traditional green, red/pure green, red/blue, and blue/pure green. RGB tricolor LEDs contain three different LED emitters in one case. Each emitter is connected to a separate LED so they can be controlled independently. A 4-lead arrangement is typical with one common lead, anode or cathode, and an additional lead for each color. Others have only two leads, positive and negative, and have a built-in electronic controller. RGB LEDs consist of one red, one green, and one blue LED. 136. By independently adjusting each of the three, RGB LEDs are capable of producing a wide color gamut. Unlike dedicated color LEDs, these do not produce pure wavelengths. Modules may not be optimized for smooth color mixing. Decorative multicolor LEDs incorporate several emitters of different colors supplied by only two lead-out wires. Colors are switched internally by varying the supply voltage. Alphanumeric LEDs are available in 7-segment, starburst, and dot matrix format. 7-segment displays handle all numbers and a limited set of letters. Starburst displays can display all letters. Dot matrix displays typically use 5-7 pixels per character. 7-segment LED displays were in widespread use in the 1970s and 1980s, but rising use of liquid crystal displays, with their lower power needs and greater display flexibility, has reduced the popularity of numeric and alphanumeric LED displays. Digital RGB addressable LEDs contain their own smart control electronics. In addition to power and ground, these provide connections for data in, data out, clock and sometimes a strobe signal. These are connected in a daisy chain. Data sent to the first LED of the chain can control the brightness and color of each LED independently of the others. They are reused where a combination of maximum control and minimum visible electronics are needed, such as strings for Christmas and LED matrices. Some even have refresh rates in the kHz range, allowing for basic video applications. These devices are known by the part number WS2812 being common, or a brand name such as NeoPixel. Filament and lead filament consists of multiple lead chips connected in series on a common longitudinal substrate that forms a thin rod reminiscent of a traditional incandescent filament. 137. These are being used as a low-cost decorative alternative for traditional light bulbs that are being phased out in many countries. The filaments use a rather high voltage, allowing them to work efficiently with mains voltages. Often a simple rectifier and capacitive current limiting are employed to create a low-cost replacement for a traditional light bulb without the complexity of the low voltage, high current converter that single diodes need. 138. Usually, they are packaged in bulbs similar to the lamps they were designed to replace, and filled with inert gas at slightly lower than ambient pressure to move heat efficiently and prevent corrosion. Chip on-board array surface-mounted LEDs are frequently produced in chip on-board (COB) arrays, allowing better heat dissipation than with a single LED of comparable luminous output. 139. The LEDs can be arranged around a cylinder, and are called corn cob lights because of the rows of yellow LEDs. 140. Considerations for use. Power sources. Simple LED circuit with resistor for current limiting. The current in an LED or other diodes rises exponentially with the applied voltage. See Shockley diode equation. So a small change in voltage can cause a large change in current. Current through the LED must be regulated by an external circuit such as a constant current source to prevent damage. Since most common power supplies are, nearly, constant voltage sources, LED fixtures must include a power converter, or at least a current limiting resistor. In some applications, the internal resistance of small batteries is sufficient to keep current within the LED rating. Electrical polarity. Unlike a traditional incandescent lamp, an LED will light only when voltage is applied in the forward direction of the diode. No current flows and no light is emitted if voltage is applied in the reverse direction. If the reverse voltage exceeds the breakdown voltage, which is typically about 5 volts, a large current flows and the LED will be damaged. If the reverse current is sufficiently limited to avoid damage, the reverse conducting LED is a useful noise diode. By definition, the energy band gap of any diode is higher when reverse biased than when forward biased. Because the band gap energy determines the wavelength of the light emitted, the color cannot be the same when reverse biased. The reverse breakdown voltage is sufficiently high that the emitted wavelength cannot be similar enough to still be visible. Though dual LED packages exist that contain a different color LED in each direction, it is not expected that any single LED element can emit visible light when reverse biased. It is not known if any Zener diode could exist that emits light only in reverse bias mode. Uniquely, this type of LED would conduct when connected backwards. Safety and health. Certain blue LEDs and cool white LEDs can exceed safe limits of the so-called blue light hazard as defined in eye safety specifications such as ANSI /ESNA RP 27.105. Recommended practice for photobiological safety for lamp and lamp systems. 141. One study showed no evidence of a risk in normal use at domestic illuminance. 142, and that caution is only needed for particular occupational situations or for specific populations. 143. In 2006, the International Electrotechnical Commission published IEC 62471 Photobiological Safety of Lamps and Lamp Systems, replacing the application of early laser-oriented standards for classification of LED sources. 144. While LEDs have the advantage over fluorescent lamps, in that they do not contain mercury, they may contain other hazardous metals such as lead and arsenic. 145. In 2016 the American Medical Association, AMA, issued a statement concerning the possible adverse influence of bluish street lighting on the sleep-wake cycle of city dwellers. Industry critics claim exposure levels are not high enough to have a noticeable effect. 146. Advantages. Efficiency. LEDs emit more lumens per watt than incandescent light bulbs. 147. The efficiency of LED lighting fixtures is not affected by shape and size, unlike fluorescent light bulbs or tubes.